so that when they're talking about all the good stuff you're doing, nobody hears it. But also some of the other stuff you're doing. And it's not that we want nobody to hear it, because we can learn from other people's mistakes and issues. And, yeah. So, in light of that, I found a box that says Champion Aerospace Ignition Harness. We have not talked much about Champion harnesses, but if you're one of those guys that can put 2 and 3 together to make it 9, or however that works out, 6. 2 and 3 together to make it 6. That's where I was. No, 6. Because if you take the plus and turn it sideways, it becomes a 6. 2 times 3 is 6.
You take the 3, the exponent of 2 is 9.
Oh, see? I knew it. I knew you could put 2 and 3 together and make it 9. So exactly, what does that have to do with anything? So I have high hopes for Cheddar that he can tell me. Why haven't we been talking about Champion at all? But anybody? Before I open the box? Anybody want to take a guess?
What happened?
Yeah, we've been talking about Slick, I've been talking about Bendix, I haven't even mentioned Champion. Well, not necessarily all the same, but Champion did buy Slick. So they kind of maintain the name-ish, but if you want to go buy a Slick something or other nowadays, you're actually going to be buying a Champion something or other nowadays. So, and this box isn't new, so it's not exactly a new development. So, as we do a little unboxing, I'm not sure, I don't even know what generation y'all are. I know there's a couple of them, but I gave up when I wasn't sure what generation I was. So, but you know, the age of YouTube and TikTok. So I unbox it. Whoa, why do we have the fancy plastic things on the end? Anybody? Protection for what? What am I trying to protect? The spring, because yeah, the spring's on there. Well, you guys know, springs can get a little iffy. So I have a Champion one. Boy, this looks like it goes on what kind of mag? Bendix. It's got the witch's hats that Dean doesn't like. I mean, I don't like them either on there. So yeah, this is for a Bendix mag, even though it's a Champion kit, which is basically a slick wire. So inside this thing, hopefully, it actually might be making me a liar now because it might be so old. Normally, it would have the slick wire in there. Oh, tempted to cut it apart and see. Because the witch's hat on this end, it's hard to tell. It looks crimped. And if it's crimped, it's not going to be crimped around the spiral one. So anyway, that's not what I was going to show you. What I wanted to show you was this little bag of parts. And this was, I thought, Randall's maybe favorite part. On here, it's got a list of FAA, PMA, interesting information. And right in the bottom of it, but it says there are 20, part number LTB-T550 tie wraps. Oh my word, right there. And I've never seen one of these ignition harnesses installed anywhere except the engine compartment. So it's this little bit of a, you know. So that said, what else did they include in there? Clamps, the dowel clamps. So the wires are neatened up, tidied up to get together with the tie wraps. I'm still not going to call them zip ties, but with the tie wraps. But primary security is still going to be with the Adele clamps, right? So anyway, I was going through the box and I stumbled across that right in there with brand new kit. They're sending me tie wraps to install in the engine compartment from the. I was like, you've got to be kidding me. So I still hold to that if you're following AC 4313, we're in a gray area here. And I've never seen lacing fail with age or heat. But it is fairly industry standard to neaten up a bundle with a tie wrap. So anyway, moving on, but I highly recommend continue to practice lacing because it's pretty easy, you get good at it. what we're hoping for.
You can put a slick ignition harness on a flatback spinning wheel.
Mm-hmm. The wires are better.
Or just,
It wasn't necessarily in there. All gonna depend on how they do the part number. But, it's gonna be an STC, it's a wired. That's a good question. If I was buying one, I'd be double checking if it came with an STC or how that works.
yeah.
Yeah. Okay. I made more mag stands, those little boxes to put mags on. They're not as high quality construction as the ones Dean had. I didn't paint mine when I got done, or varnish them or whatever you put on the outside. But they're gonna work. So they're out on the table. If you're working on mags and you need a little stand, hope you enjoy them. I did it just for you. I gotta run through attendance real quick. I think it was just Goodhue that walked in late, which was funny because I thought when I looked around earlier, we must have had one empty seat. So, got that done. And we are gonna review the exam. So Randall, get out of here. Best wishes. Unfortunately, it won't be great on a curve because ice cream, but maybe you can be one of two. Maybe you can be one of two. So Clayton, are you okay? Clayton.
Yeah.
Clayton, are you okay? If everybody knows, everybody give Clayton a round of applause. There were two other students that, at least two, that only missed it by one question. And after review, I was like, they knew that. They all missed different questions. Three, actually. Three that only missed it by one question. And I thought for sure I was going to be grading on a curve until Clayton's grade came in. So somehow I did go through and update question 28s, all the question 28s. So your grade may have changed slightly since when you originally saw your grade. So let's review this. I'm just gonna take myself a note before I forget. Alright. Number one, EGAP, and EGAP, it's a kinda, EGAP is where the contact point's open, it's where it sparks. Now, we're assuming everything is set up correctly, right? If you set up the points to open way too early or way too late, are they opening at EGAP? Debatable. But a lot of these questions, we're assuming it's set up correctly. So EGAP is where the points open, and gap, I remember it like the EGAP, that is a gap between neutral and where the points actually open is how I understand it to be. But EGAP is defined as the number of degrees between the neutral position and the rotating magnet and the position where the points
That's
open.
EGAP angle. This EGAP is,
EGAP angle. Yeah.
so what's the difference between EGAP angle and EGAP?
So if you were gonna draw a 360-degree thing so you can keep track of how many degrees you have of rotation of the prop, basically what they're saying is neutral would be 0 degrees on your rotor. And then where we want our points to open, somewhere just past that, is EGAP. So they're saying this angle is EGAP angle.
But the point's still open at EGAP.
Point's still open,
Oh, okay.
so
Yeah.
yeah, it's just that kind of vocabulary term to. We could have done away with a little confusion if we were the FAA and wrote this, and we would have just said points open, but that sounds like something happening, so they gave it a name. It's like a destination.
Yeah.
You have arrived at EGAP.
And what is greatest magnetic flux density? When does that happen?
The greatest magnetic flux in what?
Oh, in the, yeah.
Um,
I guess if it's in the magnet, it would be, or in the metal, it would be,
So
what is that?
in the bar is gonna be at full register.
Yeah.
Greatest radius in the coil is actually going to be pretty much at neutral, and we didn't touch on it too much, but the reason we do it slightly after is kind of like we talked about on a swing. You don't want to get kicked, you don't want to kick somebody at the very, very bottom. You want to kick it just a little bit later, kind of like in golfing. If you want to launch that ball, if you're hitting with a driver, you put the ball on your front foot. It's just barely after the bottom, and it'll launch it the farthest. So, anyway, these little tricks. So the gap is just a little bit after the bottom. Not sure that technically correlates, but it literally correlates. Positional. All right, when a shower sparks ignition system is activated at an engine start, a spark plug fires, and it's only when both the retard and advanced breaker points are open. Hey Shane,
Sure.
I don't know if he closed his doors all the way. Could you close our back door? Just because I yell loud and want to make sure Randall's not just following along. I don't think he would.
He wouldn't do that.
But not on purpose, at least. Not on purpose, at least. Advance are the early ones, so it can't be when the advance point's open, and it's not when they're closed. So. Number 3, what component of a dual magneto is shared by both ignition systems? I had quite a few people get this wrong. If you just picture it in your head, I got dual magneto, so one part bolts onto the engine, so something that bolts onto the engine is driven by the engine. That's the part that's going to be shared. What's the engine doing? It's spinning a magnet. And then we bolt onto there, I should say bolt on, cast in, the 2 distributors are sitting on the top part. So the rotating magnet is what is shared, and once you get past the rotating magnet part, now we're going to start having 2 systems. Does that make sense, everybody? That one was a little surprising to me, how many people got that one wrong.
He's curious.
Yeah.
Is that magnet for a dual magneto stronger than for a normal magneto? Because it's producing.
I don't know the answer to that one.
Just curious.
Yeah. How many secondary coils are required in a low tension ignition system? We talked about this a bit. So if it's low tension, that means we have that step-up transformer, or we would call it a coil pack, at each spark plug. And how many spark plugs do we have on each cylinder? 2 spark plugs per cylinder in aviation. So if I got 18 cylinders, I better have 36 spark plugs. So that means I'm going to have 36 secondary coils. 1 coil for each spark plug. Number 5. After magneto housings, magneto housings are usually ventilated in order to, I'm pretty sure this was a prep word, provide cooling. We got electricity, and if you're like me, you're like, I'm going right from ground through a coil back to ground. So I do have amp draw, so I have amp draw through a wire that produces heat. So we do got to get rid of that heat, and then also the corrosive gases, namely ozone. We have the spark at the distributor, that where the little finger doesn't touch the backside of the distributor finger, just a tiny little gap. That produces spark produces ozone. Ozone is corrosive, so we want to get rid of that ozone. It wasn't in this test, but if we're flying high altitude with our magnetos, what else is going to be kind of tied into that question?
Pressurized?
Pressurized, yeah, because we don't want that spark finding somewhere else to short to inside that magneto housing that's not pressurized. So they'll plumb in some turbo, I think they call it upper deck pressure, some turbo pressure to our magneto to keep the distributor pressurized. Mr. Ward, do you have a question with that? Or comment?
Did you meant that in left?
Yeah.
Meant to.
Twice, 3 times. I pointed out the vents quite a few. Talking about how sometimes our tach pickup, if we have an electric tach, goes right in the vent. That tach pickup will still have a hole in it, so we can still vent the stuff. That was one of the ways we mentioned it. When using a timing light to time, and I'm not saying that like talking down, but just hopefully it like triggers in your head. You're like, oh yeah. You hear it a couple times. At least for me, it sinks in. When using a timing light to time a magneto to an aircraft engine, the magneto switch should be placed in the. I actually don't like this question because I'm not an automotive guy, but they make these little gun things that like shoot, and call them timing lights. I don't know if you guys ever, as the engine spinning, any automotive guys? Yeah, right? The first 10 times I read this question, I'm like, I've never used a timing light in my life. And then I'm like, oh, the mag synchronizer box that has the little light bulb on it. So when using timing lights, timing magneto for aircraft engines, the magneto switch should be placed in the both positions. Yeah, both. Left or right, either one, sounds like it might be an okay answer. But if I'm trying to time the left mag and I put it in the right position, that would not be correct. It's definitely not as good of an answer, because I could put the switch in the wrong position. So both position is what we want to set this thing to. It's the best answer. I think I stole it from Prepware, so that when you see that again, you're like, got it. Question 7, which of the following obtained during a magneto check at 1700 RPM indicates a short or grounded circuit between the right magneto primary and the ignition switch? So a short or grounded, meaning that that magneto is not going to fire, right? Because essentially the breaker points, the contact points, are not opening. So basically, which one of these is going to say that our right magneto doesn't work? So if I go to my right setting, because right is I'm running only my right magneto, I'm going to get essentially 0 RPM, because when I'm set on right, we're not functioning. So this one has right 0 RPM, this one has right 0 RPM, that one doesn't. So it's got to be one of those first two. So we go to this one, both would be 1700. Right, I get nothing. Left, I get 1675. Wait a minute. If my right is not working the whole time, why would I have any difference between both and left? I wouldn't, because if my right's not working and I run the throttle up to 1700 RPM, I'm only running on the left magneto, correct? Because my right's not working. So I'm only running on the left, so when I switch it to left, there should be no change in RPM. So that one can't be right. So that's why at 1700, engine dies, and if I'm running on left, well, that's the same thing as running on both if my right magneto is dead, and then off, it dies again.
Oh, never mind. Well, like, so if the right was functioning, you would have a nice job.
So if everything was working correctly, we would get, I'll give you option D, on both, you'd get 1700, and we'd get 1700 because, well, that's where we set the throttle, right? If the engine's running, I set it 1700. If I go to right only, I'd get, we'll go 1675. We want to drop somewhere between, was it 50 and 150, and we care more about them being the same between right and left than we do how far it is. But, so right 1675, left 1675, and off 0. So that's what you would get if things were working correctly. Now, the 1675, we could be anywhere from, let's say 16, we'll go with 1675. We could be anywhere from 1675 to 1550, and we're not going to say I'm not flying today. We're going to go, we're going to take note of that. Because how far they drop is less consequential than they do drop, and I have the same drop or very similar drop between magnetos. The reason you might get a little bit different, and we'll cover it more in spark plug class, is if my bottom plugs or one of my magnetos is not functioning well, if one magneto is giving a better spark than the other magneto, and maybe I get a 50 drop on one and 150 on the other, I go, oh, that's weird, because I usually expect them to be essentially spark my cylinders exact same. So that's that one. This is part of why I'll go check with Ava when we're done. Be like, I'm giving you really great info, Ava. Where'd you go?
I think she's got her written.
Oh, that would totally make sense. When does the ignition event occur? During normal operation of a 4-stroke somewhere in the middle. So, normal operations, they're not talking starting. Starting is not normal operations, otherwise we would say during starting. So normal operation is before the piston reaches top dead center on compression stroke. It's printed right on the name tag, exactly where it's at, right? It'll say set it to 22 or 23 or 25 degrees. The spark in the secondary circuit happens when? And it's when the contact points open. I'm not sure why we have spark in the secondary, because hopefully there's no spark in the primary circuit. There shouldn't ever be a spark in the primary circuit, but they're just giving you one more piece of info to make you think. They want you to slow down a little, and I will point out some of our not as good grades were the people that got done first, especially on an exam like this. Slow down and take your time. True or false? The rotor in the distributor of a 6-cylinder magneto turns at half the RPM as the engine, just delivering 3 spark vents for each rotation. So a rotor is always going to go half RPM. Now, I've got to double check my math if it's a radial engine. I always have a problem with radial. I want to say rotary. If it's a radial engine, those magnetos are a little different. We're going to go over them in detail a bit later. I'm not 100% sure those turn half RPM. I think it might still, but I got to double check my math. But on our horizontally opposed engines, that distributor rotor is always going to be half the RPM of the engine, because 4-stroke engine, the pistons have to go up and down twice, right? Up and down twice for every time it gets a spark. True or false? An impulse coupler both speeds the magnet of the magneto and also delays the spark event when in use. That is true. That is true. When is an impulse coupler activated? And it's when the magneto is turning slowly. If you turn the magneto fast, they don't catch. If I just turn the ignition switch to the start position, number 1, if the battery's disconnected, my impulse coupler is not going to work. Right? I can turn it to start all day long and no impulse coupler. I can go to the other extreme and turn it to start and hold it there. The impulse coupler is clicking, and oh! If I don't let go of the start switch, my impulse coupler is not activated anymore because the engine's spinning fast enough that those dog legs have done their centrifugal thing. So it's not when it's placed in the start position, it's all about how fast the shaft on the magneto is spinning. Alright, starting to get to the fun ones. 13. When timing the magneto to the engine, first remove the spark plugs. Spin the magneto appropriately so the magneto is timed. And find the compression stroke. I guess that would be, if it's a slick magneto, but find the compression stroke of cylinder number 1. Use the metal finger and chrome dome to find top dead center, then move the engine to the appropriate advanced timing position and bolt on the magneto. If you think you found a way to answer these ones correctly that got marked wrong, come see me afterwards and I will look over them with you. Or if you just think I got them totally wrong, you can shout out in class and we can talk about it. But every once in a while somebody surprises me with some creativity, kind of like using 2 and 3 to get 9, and I go, didn't see that coming. Alright, how many cylinders? Should be easy. 6, right? 6 cylinders. Match the engine with the timing marks. Valve push rods are on the top of the engine. That better be Lycoming. No valves for air. That would be your turbine, right? We don't have any valves to let the air into a turbine engine. That'd just be silliness. Valve push rods on the bottom, Continental. This was just, I had it, with matching questions, there's got to be 3. So I'm just like, you know what, I'm going to give them a free one, give them a bonus one. I didn't even look if anybody got that one wrong. Hopefully nobody got the turbine one wrong with those. True or false? The P lead is connected to ground to allow the magneto to send spark to the spark plugs. No. If the P lead is connected to ground, there's no spark happening, right? So the P lead would be disconnected from ground. If if your P lead is not even on the aircraft, I take the wire off, am I gonna have spark or no spark? Spark. I'm gonna have spark. So the P lead doesn't allow the magneto to send spark anywhere. The P lead grounds the primary, so we do not get spark. That's what the P lead is for. That make sense, Shane?
Well, I spent some time on this, I was thinking through, replacing wires, and I was like, we did attach the P lead to the, the shell of that magneto, like, it is connected to ground. So I understand that's not so it can then send a spark.
Is to shut that spark off. Yeah, it'd be kinda like saying our fuel shut off is on there so we can burn the plane down when it crashes. Like, no. The fuel shut off is so we stop burning the plane down when it crashes. Alright, Mr. Goodhue.
So the P lead is more or less like a leash on a dog.
Yeah, the P lead is a leash on the dog. Exactly. So we have some semblance of control over that magneto. Which means if it breaks, your dog got off the leash. But in aviation, we have double safeties. We also have a shock collar or something. We can shut the mixture off to shut our engine down. Alright, on a magneto with a retard contact point. I got a grammar problem in that one. On a magneto with a retard contact point, the retard. No, that's still good, because there's 2 points that come together,
It would just be with retard contact points.
not a, with
Yeah.
retard, yeah.
Yeah.
Alright, the points open, and it's after, they're slower, they're a little slower. Kinda like me sometimes. 18. A high tension magneto is said to have 3 circuits. The magnetic produces the energy, the secondary winding. See how I switched the order on you just to make you read it slow? The secondary winding circuit is connected to the spark plugs to provide spark. The primary has less windings and is connected to the P lead. We ground out the primary. Now, some of you might say, the secondary is connected to the P lead too. It's the same plug-on thing. And I go, well, most of the time, but the primary is surely not connected to the spark plugs. And tomorrow we'll show you some circuits that, yeah, I don't think the secondary is connected to the P lead. I'm picturing it in my head. You can wire them different ways. That is a great spot to stop and mention that. I've been talking over with you guys on your magneto. If there's your magnet, there's your, I do that every time. There's your circuit for your flux, if you will. So we'll put a little bar in there and we're gonna wrap some coils around this thing. So, primary coil, ground through contact points to ground, and I don't know how to draw a lifter with a cam, but we'll draw it like that just so you get the idea at the moment, right? You guys good with my drawing so far? Is this magneto I gotta add another coil, but it's gonna work. It's gonna work eventually. Alright, so I'm gonna come in here, I'm gonna draw a secondary coil. I'm gonna go, I'm gonna come out with my wires. I'm gonna go to ground, and then I'm gonna go to my distributor that eventually goes out to a spark plug to ground. Is that magneto gonna work? So notice I separated my secondary from my primary. That magneto will work just fine. That one's gonna work just fine. That's kind of the old original version of what we actually did. Because what causes the spark in the secondary? It's the collapsing field that the primary made a field. When that field collapses, when we open those contact points, it's that field collapsing across in space the secondary. So I got ground through my field, through a spark plug, back to ground. That will work just fine. This is the simpler version of how a magneto works, if you want to phrase it that way. But our engineers came along and said, I got some more wires in there, I got some more coils. Why don't I just hook him up to here, and now I've got a little bit longer winding when it collapses across, I get just a little bit better efficiency. So this is what we have on your magnetos, because they said, I'll get just a little bit more winding inside. But the actual function of it, when you're thinking about how a magneto functions, it might help you, to think of it that way. It's a little bit simpler. That is more direct on our chain of events of how a magneto works. Magnet spins, I get a changing flux. Changing flux causes a current in my primary. Current in the primary causes a field to build and collapse. And it's doing that not very fast, but if we catch that field at its largest point and then open a contact, it'll collapse super fast. That field collapsing across our secondary induces a super high voltage on the secondary that causes a spark to jump a gap at the spark plug. That is the chain of events. That is how a magneto works. So if you get anything to that effect on O's and P's, or somebody asks you how a magneto works, talking through that is what you're going to have to do to show understanding. That's the best way. Now, you could get off in the weeds on some of those and say, we're going to open the points at just after neutral. You could say that point we open them is E gap. You could say other stuff about impulse couplers and whatnot. But being able to just go through the magnet spins causes flux, changing direction, changing flux causes current, current causes field, field build, collapse, build, collapse, build, collapse. When it's the biggest, if we open the contacts, it collapses fast, fast collapse across secondary causes spark. You can get that string of events memorized, that's what you need to know on a magneto. Whew. Okay, Lycoming. Lycoming engine. When the top center line is aligned with the dot on the starter, the engine is. And it's not at the bottom. That would be silly. That would be at bottom center. And it's not at the correct place for the magneto to be installed, because we want to install the magneto a certain number of degrees before that, right? Whatever's stamped on the engine. So top center. So if we found top, but we better back off the prop however many degrees.
Case, do we use TC and TDC semi-synonymously?
I do.
Okay.
Yeah, top dead center. It's kind of like, do you want $10 or do you want exactly $10?
I'll take $10. But, okay.
Yeah. Stamped on the flange on a Continental does not say TDC. You get a T in your line and your indicator. So I would use that as evidence in court to say I'm not wrong. Using top center quite often. A lot of the stampings are going to be TC, 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 TC. Maybe in a book they probably throw in dead just to, exactly, but yeah.
Isn't top center where the movement of the piston is negligible, but top dead center is when the piston is perfectly in line with the rod?
Back to, if you want it in writing, we could check Crane's dictionary, and they may separate those that way, but stamped on flanges, stamped on rings, they often don't put the D in. We're gonna do TC, and it's exactly top dead center. So you can't get any narrower than the line.
Yeah.
So yeah, we're gonna D just adds exactly to add more words. Amanda.
I was confused on this one because not the one that you currently have, the previous one, because I thought it was only had to do with I thought we were only trying to find compression. So I just never remember hearing, oh, make sure it's on the exhaust strip.
So, okay. I find with my thumb the compression stroke. Let's see. There we go. I would get pressure coming out right there. That's my compression stroke, okay? find top center, top dead center, right there. If this was a continental, I would have a mark on the bottom of this that is lined up with the bottom split on my case. For you guys, I'll put a mark on there, okay? So this is top center, top dead center on my compression stroke. Now, if I come around a whole nother time, my exhaust valve is open, and the piston is again at top center, but this is not the compression stroke. So just because the line is lined up, it might be the top of the exhaust stroke, or it might be the top of the compression stroke. So that's why we need to make sure we have the pressure coming out when we're doing this timing. We gotta make sure we're not on the wrong stroke.
It doesn't matter that it could be compression or exhaust.
Well, when you mount a magneto on there, you don't want it to spark on the exhaust stroke, or you'll be the student that when you start up the engine, it goes bam, 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 and it lights off the exhaust instead of when it should on the compression. You absolutely want when you mount the magneto, you mount it with it pinned or the little paint thing in the window so that you're mounting it right where you're gonna get the spark. You want that spark right just before the compression stroke. You don't want it on the exhaust stroke. So you absolutely gotta make sure you're not on the exhaust stroke mount the magneto.
Why does it say or an exhaust stroke?
What? Because I just said the line. So like that line I put on there, right? When it's lined up with the bottom of the crack, I might be on the compression, I might be on the exhaust. So that's how the question's written.
So the question's not asking when you're it's just asking.
The question only states when the TC line is aligned. Yep. Didn't give you any more info than that. If an engine states 22 degrees, the contact points on the magneto should open when the crankshaft is 20 degrees before top center. That's number one, that's true. That's what we're trying to do in this class. Okay, this one, I'll admit, a little tricky. Some of you guys that got it wrong, I was looking at the one you got wrong, and I was like, no, that's correct. And I'm like, oh, it's correct, but we asked you to mark the incorrect statements, right? Which three statements are not true? You're looking for false statements. So the ones highlighted in green are false. It's not just after full registers, it's just after neutral. It's not when they close, it's when they open. And it's not when they close, it's when they open. So we highlighted, you had to pick the false statements. The other three are true. They open at E gap, they open just after neutral, and, well, spark. And we get spark when the retard breaker points open. So the ones you don't pick are the true statements on there. And I purposely wrote it that way, not to be mean, but to get you to slow down. Basically, I had too many true-false questions, and I'm like, true-false questions are boring. I'm gonna put 3 true-false questions in one question body to make you slow down and think about this. Same thing with this one, right? Except I didn't reverse die. So this one was a little easier. It just says select the true statements. I'm gonna go through, yeah.
You know, it would be even better is if you were to swap those two questions
Why?
for next year, so that they go through and answer all the correct questions, and then the next question is,
The backwards one?
yeah.
Just, maybe I'll do that for all the retakes. Actually, I was thinking about that. A lot of times with exams like this, your retake is not the same exam. So when I'm getting some of the people that are rifling through really quick, and then I think they get all the free answers on this review, we get that again in the next class. You might get one of Dean's exams for the retake, which would be a whole nother flavor, because you'd be like, I've never taken a Dean exam. And I'm like, well, you know how to read. You'll figure it out. His were open book. And you just sit there and flip through your textbook until you found the answer. Which, some of them were interesting, but you can imagine electrical class trying to find the answer. So you really wanted it memorized, and basically you could get about an 85 to 90 without opening your book, usually. And if you wanted 100, you'd just sit there and be like, I don't know where you got this question from. But it would be in there. It did teach you to use your book. There is that piece. True or false? Surefly and most other electronic magnetos do not require external electricity. They do require, I put most other and electronic, they require a battery. They actually require a battery backup so that if your battery fails, it'll still work. Now, they are coming out with ones. Surefly, does the magneto provide power to itself? But they want you to know that there's supposed to be a battery backup if you're using it for your primary magneto. So you can put like a Surefly in, and you can have it be a backup magneto. It can be like, hey, this is only on here to run well, but you can't have two Surefly magnetos. You can't have that without having a battery power source to get it going. So they need a power source to get things running.
If you have to have the battery backup, you have, like a separate wiring harness, if you have separate wires, or they use the same wire?
We'll go over that in a class. It all depends on at that point, all depends on manufacturer and what they're doing.
It's not a requirement.
Yeah, typically what they do is they'll mount a little battery about half the size of these ones, somewhere in the engine compartment or airplane. And it's only providing, probably a third the size actually, it's only providing a little power to it. So kind of think of it like when you're starting, when we're starting the aircraft, Sureflies and smaller ones, they do have little like generators in there, but you're not spinning it fast enough to get it to power up all the circuit boards and everything going on is the general rule on those E-mags. So at starting especially, they have a power source to power everything up. Once everything's running, sometimes they'll have rotors that would provide enough power to keep it running, but a lot of times if there's no external power source, like you're not gonna hand prop an engine with a Surefly. Unless there's a backup power source for it. That's probably the best way to explain that. No hand propping E-mags unless they have a backup power source.
That's not safe aircraft.
So the Surefly mags and the E-mags just shouldn't use the timing.
Depends how they're set up. Yeah, we'll have a lecture on that. It's a good one. I like it. It's fun. All right, 24. We're getting close. Most Bendix and slick magnetos will continue to send sparks to the spark plugs even if the battery or power supply of the aircraft fails or turns off. That's true. So that's the inverse of like the E-mag Surefly thing, is we don't need any power source for Bendix and slick magnetos. True or false? That's a Bendix. That's a Bendix mag. So that would be false. True or false? This is a Bendix. No, that one's a slick mag. So that's false too. I got you with two false ones. Wait, what did I say on that one? That shows a slick, so that's false. Yeah, we reversed them on you. This is a slick mag, but I asked if it's a Bendix. The other one was a Bendix mag, and I asked if it's a slick. So on both those, you gotta know the difference. The image shows what? So you got the springs coming off, that's the harness, so it's one of two wiring harnesses. We got two mags on each aircraft, right? And there's 4 springs, so it's for a 4-cylinder engine. And what kind of magneto? Well, the springs are on the harness, which means they're not on the magneto, so that's gonna be a slick magneto. A Bendix magneto won't have springs. A Bendix magneto has the witch's hats on it. There's a drag and drop one. Ooh. No, I think I got it corrected, so Randall should have hopefully had the correct answers. Main thing was here, I had to go in and correct that for Clayton's. So he got it correct because right here at this exact moment, there is not spark happening because the contacts are closed. If you look at the picture, the contacts are closed. The sparking will start when the retard contact opens after the advanced contact. Lastly, the right magneto is supposed to be is not installed with an impulse coupler. So I changed that around so it's correct on the next one. And I think what this is. Bob split line. Continental. Didn't we ask this question one? Oh, the other question is say Continental versus Lycoming on valve push rods. Lycoming's top dog. This one is, okay, now that you know what kind of engine you have, tell me how to line up where the top center. So the bottom split is with Continental, top split is with Lycoming, it's the top dog with the top side push rods. And timing mark under plug and nose cone of engine is gear reduced radial engine. There's a prep work question that likes to ask you that. I showed you some pictures, so I was throwing it to you one more time. Because if you got a geared engine, we can't just go off the prop flange because the prop's going a different speed than the crankshaft is, so they're not gonna match up with each other.
Are you done with this question?
Sure.
Can I make a suggestion for question 21?
You can suggest.
Could you, so there were three, was it incorrect statements? And then there were, I think, three correct statements.
Okay.
Can you change it so that, like, you know, if someone is, they have it opposite than the original language?
There are 4 correct statements.
Or four correct? Is it full registered is also? It's just after
What
full
are-
registered.
what ones are not true? So there's actually 4 true statements here. One true is immediately when the main breaker point's open. So there's 4 true ones. I think I already did your suggestion.
Yeah, for my explanation, it just has three listed for the, what should have been there.
Well, there's 3 false, but there's 4 correct.
False ones.
Statements.
There are 3 false ones, which are the correct things to choose to get the right grade. But
It must,
there
it
are,
must be Moodle because it says your answer, like for mine, your
Yeah.
answer's correct, the correct answers are, and it lists just 3 of them.
So the
Yeah.
correct answers for that question.
the correct
belong
answer, yeah.
Oh, that is confusing, because it says the correct answer is for the incorrect statements.
I'll go over it with you in person.
correct statements.
Okay. Oh, was that the last question? That was the last question. Okay. That's what I got. So the correct answers are the false statements. So maybe I would put in there the correct false selections are those 3 you have to select. Okay. Lab time. There we go. And this is gonna become more and more normal, 1 hour a lecture-ish, 3 hours of lab time. Oh, I did write up here, the aircraft engines that I've been told run, and hopefully we'll keep adding to this list, are the IO 540 Aztec stand. I think Christian Reed Smith is working on that one right now. The Cherokee, I don't know of anybody working on it. The Grandpa, I don't know of anybody working on it. And Ryan said the 210 is back up and running after we had some alternator questions. I don't know what happened with that, but they got it going. So the 2 blue test stands, I removed the faults from the 4-cylinder one. I think that runs, and that's why we would suggest trying to start it before you remove and retime the mags. And then the 6-cylinder blue test stand with a Continental engine, Ryan thinks that runs. That one doesn't have a boost pump anymore. It's got a little squeeze thing, like if you're into boating, where you gotta prime the engine. So it's a little, I'm not sure. I don't know if I've ever started with that, but I think you can advance the throttle, advance the mixture, and prime it. And then, yeah, that could be an adventure. Now that one has a slick mag and a Surefly mag. So for the lab, timing the Surefly is not part of your lab. So basically ignore the Surefly, we know it's on there correctly. Or totally remove the Surefly and put a slick mag back on that one if you're trying to get 4 people to work on that engine at the same time. Okay, dismiss.